Let's continue our discussion in hydraulics under the topic open channel. In this video, we will solve the sample problems number 5 to 8. And here is number 5. The bottom width of a trapezoidal canal is 2.5 meters and its sides are both inclined at 65 degrees with the horizontal. Water flows at a depth of 3 meters. The slope is 0.0008 and the coefficient of roughness is equal to 0.03. Find letter A, the hydraulic radius, B, the cutter's coefficient, and C, the discharge using Chez's formula with Manning's coefficient. So here we have the width of canal is equal to 2.5 meters. And the sides are both inclined at 65 degrees with the horizontal. So this is our trapezoidal canal. So 2.5 meters for the bottom width, and the inclination, the angle of inclination is 65 degrees with the horizontal. And given also here is the slope S 0.008 and the roughness coefficient 0.03. We're looking here for the values. We're looking for the value of radius, hydraulic radius R, the cutter's coefficient C, and the discharge Q using Chez's formula with Manning's coefficient. So having this trapezoidal canal, we're looking for hydraulic radius R for letter A, and the formula is R is equal to the total area divided by the wetted perimeter P. So the perimeter that we're concerned here is these sides and the bottom. Okay, so we need to find the value for x here so that we can get the value for the area. So for the area here, we need the value of x here. Now, to get that value of x, we need to find the value of this side here. So this is x. Let's name this as x prime. This is x prime. And this is 2.5 meters. To get the value for that, so we have here the angle 65 degrees. So this is 25 degrees. This is also 25 degrees. Therefore, we get a triangle formed here wherein this is our x prime and this is our depth of 3 meters. And this is our angle 25 degrees. Therefore, to get the value of x prime, we have here tangent 25 is equal to x prime divided by 3. So x prime is equal to 3 tangent 25, that is 1.4 meter. Therefore, our x value here is equal to 2.5 plus twice of 1.4, and that is equal to 5.3 meters. 5.3 meters. Now we can now get the area as 1/2 the upper base 5.3, the bottom base 2.5 times the height, which is 3. So area now is equal to 19, no, this is 1.5. So 11.7 meters squared. So 11.7 square meters. So that is for the area. Now for the wetted perimeter, so we need to find the value of this. Okay, the sides here. So these sides is actually, let's name that as this side here. Let's name that as y. So in our triangle here, this is our y, the hypotenuse. So y here, so this is cosine 25 is equal to 3 over the hypotenuse y. Y is equal to 3 over cosine 25, that is 3.31 meters. Therefore, we can now get here the value of P, the wetted perimeter, is equal to twice of y. So that is 3.31 plus the bottom width of 2.5 meters. So perimeter is now equal to twice of 3.31 plus 2.5. So 9.12 meters. Therefore, we can now find the hydraulic radius as equal to 11.7 divided by 9.12. So our hydraulic radius is now equal to 11.7 divided by 9.12. That is 1.28 meter. So that is the answer for letter A. Now for letter B, the cutter's coefficient. So what is the cutter's coefficient? So our cutter's coefficient here is here. So this is our cutter's formula. So looking for the cutter's coefficient, this is our cutter's coefficient in metric system. So we are going to use this. So instead of memorizing the English system here, or memorizing the two of them, just memorize only one, so that if it is in English system, if the units are in English, you can just convert them into metric and then use this one formula here. So for cutter's coefficient C, so that is equal to C is equal to 23 plus 1 over N plus 0.00155 divided by S all over 1 plus N all over the hydraulic radius R times 23 plus 0.00155 divided by S. So this is our cutter's coefficient. Cutter's coefficient in metric. So we will just directly input the values here for N. So this is 23 plus 1 over N. N is 0.03 plus 0.00155 divided by S is 0.0008 all over 1 plus N is 0.03 divided by square root of 1.28 plus 0.00155 divided by 0.00, that is plus 23. Forgot plus 23. Point 008. So that is equal to so 23 plus 1 over 0.03 plus 0.00155 all over 0.0008 all over 1 plus 0.03 over square root of 1.28 equals 23 plus 0.00155 over 0.0008. So that is 35.08. So 35.08. So that's the value for Cutter's coefficient, C. Now for letter C, find the discharge using Chez's formula with Manning's coefficient. So for letter C, we're going to use the Chez's formula. So the Chez's formula is here. V, or velocity, is equal to C square root of Rs, where R is the hydraulic radius and S is the slope of the energy gradient. And then C is for the, since the problem says states that we will use Manning's coefficient C, so the Manning's coefficient C here is this one. Since we're using metric, so we're going to use the metric formula. C is equal to R raised to 1/6 over N. So using the C here, Manning's coefficient C, we will use that here in this Chez's formula. Okay. So for letter C, Chez's formula, V is equal to C square root of Rs. So this is Chez's formula. And for the Manning's coefficient C, that is equal to R raised to 1/6 all over N. So that is Manning's coefficient in metric. So we will get the value of C first, that is 1.28 raised to 1/6 all over 0.03. So our C is 1.28 raised to 1/6 all over 0.03, that is 34.73. 34.73 for C. Now we're looking for discharge for letter C, discharge using Chez's formula. So for discharge Q, we have here area times the velocity. So Q is equal to area times the velocity using the Chez's formula. So that is C square root of Rs. So that is equal to, the area is 11.7 that we were able to obtain a while ago. And then the Manning's coefficient of 34.73 square root of the hydraulic radius 1.28 times the slope of the slope 0.008. So Q, or discharge, is now equal to 11.7 times 34.73 square root of 1.28 times 0.008. So 13 cubic meter per second. So this is the discharge Q. So that's for example number 5. Now let's go to example number 6. Water is flowing in a triangular channel with side slope of 1:1 at a discharge of 3 cubic meter per second. The depth of water in the channel is 2.5 meters. Determine letter A, the specific energy, B, the fluid number, and C, the type of flow. So triangular channel with side slope of 1:1. So this is our triangular channel, and this is the side slope of 1:1, and the depth of water in the channel is 2.5 meters. So we need to find here, the first one is specific energy. Now specific energy, the equation or the formula for specific energy so for the specific energy, where is it? So since this is an open channel, so in regards to energy, there is no pressure head here for its energy. So what we will have here for its specific energy is equal to E. So we will have the depth plus the velocity head, V squared over 2G. So this is the specific energy. So to find here the specific energy given the depth, so we already have value for the depth of 2.5. So velocity, how do we get velocity? Velocity is equal for velocity we have the Q area times velocity, and we need to find the value for area. To find the value for area, we need to find first the value of the base of this triangle. And to find the base of the triangle, we need to get the value for the x prime. So this is x, and then this is the x prime. Since this is 1:1 ratio, so we know that if that is the case, so if we use the similar triangle theorem, x prime 2.5 for the depth, then 1:1, therefore x prime is equal to 2.5. Therefore x here is equal to 5 meters. So QAB, Q being, our Q here is 3 cubic meter per second. So 3 is equal to the area 1/2, the base is 5, the height is 2.5 meters, and then the velocity. So velocity is now equal to 0.48 meter per second. 0.48 meter per second. Therefore, our the specific energy is now equal to 2.5 for the depth plus for the velocity head of 0.48 squared divided by twice of gravity or gravitational acceleration. So E specific energy is now equal to 2.5 plus 0.48 squared, 2 times 9.81. So that is 2.51 meters for the specific energy. Now for letter B, find the Froude number. So the formula for the Froude number, letter B, Fn is equal to the velocity all over square root of the gravitational acceleration times area times the width. Okay, so the width of the water. So this is the formula for the Froude number. So let's fill in the value for velocity. We got it as 0.48 meter per second all over the square root of 9.81 times the area. So what's the area? A while ago, that is 1/2 base times height is 2.5 all over the width of the water. This is the base, that is equal to 5. So that is now equal to Froude number is now equal to 0.48 over square root of 9.81 times, so cancel 5, that is 2.5 over 2. So that is 0.137. That is 0.137. This is the Froude number. Now for letter C, what is the type of flow? So the type of flow here, so the Froude number, for the Froude number here, if it is less than 1, it is subcritical. If it is equal to 1, it is critical. And if the Froude number is greater than 1, therefore it is supercritical. So here, our value here is less than 1, therefore the flow is subcritical. Now that's for letter C, subcritical flow, since it is lesser than 1. So that is example number 6. Let's go to example number 7. The diameter of a sewer pipe is 500 mm, roughness coefficient is 0.012, and the slope of energy gradient is 0.002. Compute, letter A, the depth of water in the pipe if the discharge is maximum. Letter B, what is the velocity of flow? And letter C, what is the maximum discharge? So we have a sewer pipe here. Now the water level is, it says there, what is the depth of water in the pipe if the discharge is maximum? So there's already here in our handout, there's no need to use maxima minima if you can actually memorize it already. So for maximum flow of water in circular channel, it occurs when the channel is filled to a height of, it says here, the height 0.938 of the diameter. So H is equal to 0.938 the diameter for maximum flow of water. So the depth of water, that is for letter A. For maximum flow of water in circular channel. The depth H is equal to 0.938 of the diameter, and that is 0.938 of, what's the diameter? It says here, diameter of the sewer pipe is 500 mm. So this is 0.5 meter. So H is equal to 0.938 times 0.5. So that is 0.469 meter. 0.469 meter for the maximum flow of water. Oops. Now for letter B, what is the velocity of flow? For B. For the velocity of flow, since the given here is the roughness coefficient, so roughness coefficient of 0.012, so we're going to use Manning's. V is equal to 1 over n. Hydraulic radius R raised to 2/3 and slope raised to 1/2. And let's solve first for the hydraulic radius. For hydraulic radius, we have area total over P. So the area total that it mentions here is actually the area here of water. And for the P, we are concerned with the wetted perimeter. So this circumference only. So this is the value for P. So how do we solve for the values of area? So the values of area here. So this area and the value of P. So we need to find here the value for y. So for y here, so y is equal to the h of 0.469, the total height, minus the radius. So this is the radius. Minus 0.25. Since the diameter here, diameter is 0.5 meter. So y now is equal to 0.469 minus 0.25, so 0.218. So 0.469, 0.219 meter. Now we will also need here the value for x, this portion here, the value of this one. Okay, so this is the center of the circle, forming a triangle. So we cut it in the middle. This is our alpha. Let's name this as alpha okay, so we got the triangle here, so we can actually get the value for the base already. Let's name this as x. This is x, and this is radius of 0.25, and this is the y. So from this triangle, we have here x, radius of 0.25, and this is the y. So we can already get here the value for x. So 0.25 squared equals x squared plus the y value of 0.29 of 0.219 squared. So x is equal to square root of 0.25 squared minus 0.219 squared. So that is 0.12. X is equal to 0.12 meter. So we now have the value for x. Now to get the area, so we will divide this into two areas. The area of the, so area 1 for the area of the triangle, let's just say area triangle, and this area here of the sector. So let's name that as area triangle and then for AS, area of sector. Now for the area of the triangle, we need the value for, we can already get the area of the triangle here as 1/2 base, or twice of 0.12 base times height, that is the y, 0.219, and that is equal to 0.026 meters squared. Or if we get the value for alpha, so cosine alpha is equal to 0.219 divided by 0.25. Alpha is equal to shift cosine 0.219 divided by 0.25. This 28.84. So 28.84 degrees for the alpha. Or, so we can still get the area of the triangle. So, or area triangle is equal to 1/2 of the radius sine of the theta, or the angle. So this is also one formula for the area of the triangle. So we have there 1/2 of the radius 0.25 squared sine of twice of alpha. That is 28.84. So area of the triangle is now equal to 0.026 square meters. Oops, that's not yet the final answer. So we got the area of the triangle. Next, we need to find the area of the sector. For the area of the sector, we will need the value for, okay, this. Let's name this as the theta. There. For the value of theta is equal to 360 degrees minus twice of the alpha. So theta now is equal to 360 minus 2 times 28.84. So 302.32. 302.32 degrees. So for the area of the sector, we can use the ratio. Area of the sector divided by the theta equals pi over 4 times the diameter squared all over 360 degrees. So you can use this to find the area of the sector. So area of the sector over 302.32 degrees equals pi over 4 times the diameter is the diameter of the this channel, this pipe is 500 mm, so that is 0.5 squared divided by 360 degrees. So area of the sector now is equal to shift pi times 0.5 squared times 302.32 all over 360 times 4. So 0.165, 0.165 square meters. Therefore, total area now, A, is equal to the area of the triangle 0.026 plus area of the sector 0.165. Area is now equal to 0.191 meter squared. So we're done with the area. How about the perimeter? So we still need the perimeter for our formula here, RAP. So for perimeter, we can actually use another ratio. So perimeter all over the theta equals the circumference pi d all over 360 degrees. So you can use this to find the perimeter of the sector. So perimeter of the sector divided by the theta of 302.32 degrees equals pi diameter of 0.5 divided by 360 degrees. So the perimeter now, so what's concerned here in this formula about this perimeter is only from this point here up to this point, the one covered by the theta. So we really can use this formula to find the wetted perimeter. So P is equal to shift pi times 0.5 times 302.32 all over 360 degrees. That is 1.319 meter. 1.319 meter. Therefore, our hydraulic radius R, A over P, is now equal to 0.191 divided by 1.319. So R is equal to 0.145, 0.145 meter. So since we now have the value for R, we can now solve for the value for velocity. Since velocity is equal to 1 over n. N being, what's our value for n? 0.12. 0.12. 0.012. And our r value that we got is 0.145. So 0.145 raised to 2/3. What is our s? S, or slope, is 0.002. 0.002 raised to 1/2. Velocity is now equal to, so velocity of flow, 1 over 0.012 times 0.145 raised to 2/3 times 0.002 raised to 1/2. So velocity of flow is 1.03 meter per second. 1.03 meter per second. So that is for the velocity of flow. So velocity of flow. Next, we need to find the maximum discharge. So since we already have our velocity of flow for our discharge, that is QAV. The area that we got, the total area, is 0.191, and the velocity is 1.03. So therefore, Q is now equal to 0.191 times 1.03. So 0.197. So 0.197 cubic meter per second. So that's for problem number 7. Now let's proceed to our last example in this video, the example number 8. So water flows through an almost level channel 3 meters wide at 12 cubic meters per second. The depth gradually increases from 1 meter to 1.1 meter for a length of flow of 5 meters. Determine the letter A, the head loss, B, the slope of energy gradient, and letter C, the value of roughness coefficient. So this is our flow. So it says here the channel is 3 meters wide, given the width of the channel as 3 meters, and the channel is almost level. So it says there, almost level channel. So as you can see, it's horizontal, and the depth gradually increases from, so this is the depth of the water surface. So this is our water. The depth increases from 1 meter to 1.1 meter for a length of flow of 5 meters. And given our Q as 12 cubic meters per second, find letter A, the head loss. So how do we find the head loss? So from point 1 to point 2, we can use the Bernoulli's energy theorem. So for letter A, the Bernoulli's energy theorem, E1 is equal to E2. So that is since this is an open channel, we are dealing with velocity head and the elevation head. And at this side, at point 2, we will add the head loss HL there. So for E1, at point 1, we have the elevation head plus the velocity head V1 squared all over 2G equals the energy at point 2. We have the elevation head plus the velocity head plus the head loss. Okay, so we don't have the value for velocity, but we can get it by using QAV. Q area 1 V1 equals area 2 V2. Our Q here is given as 12 cubic meters per second. The area 1, of course, the channel is given as 3 meters wide, so the depth varies. So this is 1 by 3 for the area velocity 1. For area 2, that will be 1.1 times 3 velocity 2. So velocity 1 is equal to 4 meter per second, and velocity 2 is equal to 12 divided by 3 times 1.1. 3.64 meter per second. Therefore, we can substitute values here in our equation 1. So d1 is 1 meter plus velocity 1 is 4 squared over twice of gravitational acceleration equals d2, which is 1.1, plus velocity 2, 3.64 squared all over twice of gravity, plus the head loss. So what is now the value for the head loss? So head loss is 1 plus 4 squared over 2 times 9.81 minus 1.1 minus 3.64 squared 2 times 9.81. So head loss is equal to 0.04 meter. 0.04 meter. Now for letter B, we're looking for the slope of energy gradient, the slope here of the energy gradient. So from the figure, there is a triangle that is formed. Oops. So this is for letter B. So the length here is equal to 5 meters. The slope is unknown, but we have the value for head loss of 0.04. So slope is equal to the rise over the run. Therefore, head loss is equal to LS. So that is actually a formula that can be useful. So slope now here is equal to head loss of 0.04 divided by 5. So slope is 0.04 divided by 5, 0.008. 0.008. That's the value for slope. Now for letter C, what is the value for roughness coefficient N? So this is head loss, slope, and then this is N. So Manning's formula, V is equal to 1 over N R raised to 2/3 S raised to 1/2. Now how do we get the value for R? So what we're going to do here is V average equals 1 over N R average raised to 2/3 and S raised to 1/2. Now for V average, we just have to get the average of the two velocities. These velocities here, that is 4 plus 3.64 divided by 2. So 4 plus 3.64 divided by 2, that is 3.82. So 3.82 meter per second. Now for the average for R, so we need to get the values for R1, because what we're going to do here is R average is equal to R1 plus R2 divided by 2. Now for R1, we have A1 over perimeter 1. For A1, we have there the depth of 1 times the width of 3, and the wetted perimeter here is 2 times 1 plus 3. So that is equal to 3 over 2 plus 3, 0.6 meter. Now for R2, so area 2 divided by the perimeter 2. For area 2, we have 1.1 for the depth, same width of the channel, 2 times 1.1 for the perimeter, plus 3. .635, 0.635 meter. Therefore, R average now is equal to R1 of 0.6 plus 0.635 divided by 2. So this is our R average. 0.6 plus 0.635 divided by 2, that is 0.618. 0.618 meter. So substitute all these values to this formula here. So substitute them. So V average here is 3.82 equals 1 over n. So we're looking for the value of n times the R average of 0.618 raised to 2/3. The value for slope here is 0.008 raised to 1/2. So what is n? So we're going to use here 0.618 raised to 2/3 times 0.008 raised to 1/2 all over 3.82. So n is equal to 0.017. N is 0.017. Okay, so that is example number 8. Okay, so that's all for this video.